This is our postsynaptic nerve. We'll start up here with these are the dendrites. Dendrites, these are connected to the nucleus. The nucleus is surrounded by the soma, represented by this glob of thing. And then we can move on down to the axon and the myelin sheath, the neurotransmitters on top.
The gap between the presynaptic and the postsynaptic is called the synapsis, with the dendrites connected to the dendrite spines and the synaptic vessels on top of the dendrites.
And then as we keep going on through that axon and the myelin sheath, the in-between is called the nodes of Ranvier, and then on top, as we said, is the neurotransmitters that lead us to the presynaptic, which also has our axon terminal and branches which connect to other neurons. And then we start with the action potential, which is the brief wave of positive electrical charge that travels down the axon, or which can also shift the electrical charge of the neuron. The electrical impulse that reaches down the axon, once it reaches its threshold, it fires and moves all the way down without losing intensity. It really only lasts 1/1000th of a second because the channels can only stay open for a very brief period of time.
Then depolarization is when the entire neuron in its entirety gains a lot of positive energy. It's still not positively charged, but just significantly less negatively charged. When sodium channels in the neuron open up and then allow sodium to come in, which then changes its charge. Resting potential.
And then there's resting potential, which is just when the neuron is not firing or not transmitting any information. It's normally negatively charged at this state, but on the inside of the cell membrane is negative compared to the outside, which is not. And then the outside contains mostly positively charged ions.
The refractory period is the recovery time during which another stimulus given to the neuron will not lead to a second action of potential firing.
The all or nothing principle is when a neuron only fires once it hits a certain amount of stimulus. So once that amount of stimulus is hit, it does not matter how strong or soft that stimulus is. The neuron is still going to fire the same whether it's getting lightly touched or getting stabbed.
The reuptake inhibitor stops the reabsorption process, leaving the neurotransmitters in the synapses longer, which increases their effect, which pretty much means that the nerds stay in the synapses longer and just increases their effect.